The torsion constant is a geometrical property of a bar's cross-section which is involved in the relationship between angle of twist and applied torque along the axis of the bar, for a homogeneous linear elastic bar. The torsion constant, together with material properties and length, describes a bar's torsional stiffness. The SI unit for torsion constant is m4. History: in 1820, the French engineer A. Dulot derived analytically that the torsion constant of a beam is identical to the second moment of area normal to the section JZZ, which has an exact analytic equation, by assuming that a plane section before twisting remains plane after twisting, and a diameter remains a straight line. Unfortunately, that assumption is correct only in beams with circular cross-sections, and is incorrect for any other shape where warping takes place. For non-circular cross-sections, there are no exact analytical equations for finding the torsion constant. However, approximate solutions have been found for many shapes. Non-circular cross-section always have warping deformations that require numerical methods to allow the exact calculation of the torsion constant. The torsional stiffness of beams with non-circular cross-sections is significantly increased if the warping of the end sections is restrained by, for example, stiff end blocks. Partial derivation, for a beam of uniform cross-section along its length, where is the angle of twist in radians, T is the applied torque, L is the beam length, J is the torsional constant, G is the modulus of rigidity of the material. Examples for specific uniform cross-sectional shapes. Circle equals. Where R is the radius, this is identical to the second moment of area JZZ and is exact. Alternatively write, where D is the diameter. Ellipse equals. Where A is the major radius, B is the minor radius. Square equals. Where A is half the side length. Rectangle equals. Where A is the length of the long side, B is the length of the short side, is found from the following table. Alternatively, the following equation can be used with an error of not greater than 4%. Thin-walled open tube of uniform thickness equals. T is the wall thickness, U is the length of the median boundary. Circular thin-walled open tube of uniform thickness equals. This is a tube with a slit cut longitudinally through its wall. T is the wall thickness, R is the mean radius. This is derived from the above equation for an arbitrary thin-walled open tube of uniform thickness. Commercial products. There are a number of specialized software tools to calculate the torsion constant using the finite element method. Shape Designer by Mecatiles Technologies, Shape Builder by IES, Incorporated. STAAD Section Wizard by Bentley, Section Analyzer by Fournier Magic Limited, Strand 7 BXS Generator by Strand 7 Proprietary Limited. References